Hi, I'm Phil, and in this video, I'm going to propose a new course for the Chatswood High School STEM Club. And I'm going to introduce it with a mind map, starting off from the top right. Moving around, I'll talk about electronic kits that would be suitable for the course and some of the alternatives. I'll be looking at electronic CAD and linking that with the kits, developing projects, and I'll look at the overall cost. I'll make a recommendation, look at the topics in the course. I'll critique some of the kits, and I'll give you some references. So overall, this is about introducing electronics with the microbit. So it's the two of them in combination, which is important here. And the applications are in STEM education. And there's a number of goals. First, the students should have a lot of fun and be creative in developing projects. It'll be more project driven rather than theory. And hopefully it'll encourage the students to develop an interest and or a hobby in electronics. And it might also be quite useful in exploring some of the career potential of electronics and some of the skills that are needed there. And it will also complement the STEM courses at school. So the educational goals, the basic ones are, it'll be an introduction to electronic engineering, integrating both hardware and coding. And the coding will be mainly MicroPython, but it also might have some Blocky or even JavaScript. What the students will be able to do is identify and learn about electronic components and know what the purpose of each one is. I'll also develop some skills in using electronic CAD software. They'll be able to draw schematics, produce a bill of materials, and even cost what their project would be. They can simulate the electronic circuits, and they can integrate the electronics with a microprocessor unit and do some coding. The electronic circuits, they'll be able to construct that and integrate the microbit with the electronic circuits and debug their code. And as a stretch goal, students will be able to build circuits with the Raspberry Pi Pico, which was introduced a couple of years ago and is now becoming quite popular in education to replace the Arduino Uno. So with that stretch goal, the Pico can also do many projects in tiny machine learning. Okay, so the support goals are to help the school transition from its existing resources, particularly where they're dependent on using the microbit. I'm going to explore kits, and my initial reaction was to recommend Grove kits. And I started exploring some of the dedicated kits for microbit, and I'll have a look at the Seeed Studio Kit for microbit, and I'll look at some alternatives. And the main alternative I'll be looking at will be the ElectroCrow Pico Kit and adding a breadboard microbit adapter for it. I'm going to recommend a kit, and my goal there is to have a look for multiple uses: coding, electronics, and even artificial intelligence with the tiny machine learning projects. Also, the projects that I'll be constructing and developing have to fit in within a 1 hour time limit. And those projects will also be related to important things in society, things where the project can be linked to. And also, it will allow the students to keep up to date, and the kits also have to be value for money. And one of the goals is to check out each of the projects that we're constructing, make sure that it really does work and that there are no bugs in those projects, and give the students a bit of choice, a little bit of democracy, where they can choose 1 of 5 projects for each topic that I'm proposing. And I'm also interested in getting feedback, what interests the students and what's important to them. Okay, so the first kits are related to Grove electronics, and that comes from Seeed Studio. The alternative kit, and this is built around the microbit, is from the Key Studio. So the kit that I was originally proposing was the Grove Creator Kit, and it can be used with many microprocessors, but in most cases, you will need an additional hat or shield that goes on the microprocessor. For example, it can be used with Arduino Uno, microbit, and the Raspberry Pi, and the new Raspberry Pi Pico. So in this particular kit, you get 20 Grove modules, and they can do many projects, but you need to spend extra to create the projects that I've got in mind. Okay, so the Grove Creator Kit comes in 3 different sizes. There's the Alpha Kit, the Beta Kit, and the Gamma Kit. And the cheapest one with less components is the Alpha Kit. And that costs $46 direct. You would purchase that direct from Seeed Studio in China. And it is available now. And for the extras, I would recommend for microbit getting the bit maker. And this is an expansion board where it connects to both Grove modules from the kit we just talked about, and also to the microbit. Some of the extra modules include a liquid crystal display, and I would recommend the Grove 16 character by 2-line LCD. An ultrasonic sensor, a Grove servo, a mini PIR for motion detection that can detect people, and a mini van. And I would recommend that these all be purchased, even if you are purchasing the Alpha Creative Kit. And rather than purchasing the Alpha Creative Kit, you could purchase the individual Grove modules. Now, just note that it's actually quite expensive, and you still don't get this nicely sitting on a desktop without purchasing additional Lego wrappers that would allow you to mount these Grove modules onto a Lego mounting board. Now, if you look at, just take an example of the LED, it costs US $2.20. And that would compare with, say, a breadboard component, just the LED, of about 10 to 20 cents. So it's actually quite expensive when you add up all the components that are needed, despite the fact that when you get everything, it is quite an attractive layout, and it's easy to assemble. So the Grove extensions, you could not only use this with the microbit, but if you buy the Raspberry Pi Grove hat, you can use all of those Grove modules with the Raspberry Pi Raspberry Pi. And if you purchase the Raspberry Pi Pico and the shield for that, you can then do the tiny machine learning projects. Okay, an alternative kit comes from Seeed Studio, and they have a kit, the KS4003, and that comes without microbit. So if you've already got a microbit, you just buy that kit. And you can do quite a number of projects with that. These are all the components that you get in it. And if you buy the other kit, it comes with the microbit. But the key component is on the top middle, there's a breadboard adapter. And you connect the microbit to the top of the adapter, and the adapter then fits onto the breadboard. And you get a breadboard with it. A few basic components to get you going. And you can actually do quite a lot of projects with it, including quite a few robot circuits, although there isn't enough components in this kit to make a complete robot. And head off to the Seeed Studio website and you can get more details. Now, what's nice about it, you've got a complete course that includes all the code. So the students can have a go themselves at coding, and they can then compare their results with the code that's supplied by Seeed Studio on their wiki site. Okay, as an alternative, and this is quite interesting, I started examining the Raspberry Pi Pico, and from Elecro, there's a complete kit to support that. And it comes with, or you can buy an option without the Raspberry Pi Pico. Now, to support the microbit, you would also have to buy an adapter, which would allow microbit to be connected to the breadboard. And that would be an extra $15, and that can be purchased on eBay. Okay, so in this kit, around about $43 US, you would purchase it direct from China. And you would program it using the MicroPython language. But you could use Blocky if you're using the kit with the microbit. And these are all the components. So quite a lot here. So you've not only got the basic components like LEDs, resistors, some capacitors, but you've got quite a lot of intermediate components and even a laser transmitter. So you could actually do quite a lot of interesting projects, including making a robot. It has enough components for the motor drive of a robot. And on the left, you can see how it's been used in simple projects and a project using the 4-digit LED display. So quite a good kit and value for money. And this is how you would mount the microbit onto the adapter, and that would go on the breadboard. In addition to that hardware, I'm also recommending that the students learn some electronic CAD software. And there's 2 candidates for this. There's Tinkercad, and there's also Fritzen for inventors. Now, we could mention Fritzen, but I'm recommending that the students simulate and build circuits with Tinkercad. So I've explored Tinkercad now for about a year, and it's been used by other schools, and that's where I learned it from. I learned it from the support for the Hazelbrook School in New South Wales. So I've developed a few circuits, and I've also created a Google Classroom and a Chatswood Electronics classroom on Tinkercad. And the students only need to get a nickname. They don't have to get a Tinkercad site code. They can get the code from me, and I can give them a nickname. Okay, so if we were to go ahead with the Grove electronics, we've got the Grove base kit, the creative kit, for $46. Bear in mind that's US dollars. We would have to also get the extra and the extension. And US dollars wise, that's $124 US, and it doesn't include delivery. And I'm also recommending some extra electronics. And these components can be built on Tinkercad, but they can also be physically built using the breadboard. So all up, that's actually quite expensive. And if we look at the kit that I'm recommending, which is the Elecro Raspberry Pi Pico Kit, and include the breadboard adapter, we're talking around about $100, and that's Australian dollars, including delivery per kit. So what I'm proposing is that the courses outline that I've got here, so there's the topics. There are 6 topics altogether over 12 weeks, and I would enable all the projects to be housed on the breadboard, on Tinkercad, and on the Seeed Studio, and on Grove, and also on the Elecro Pico Kit. And that's the recommendation that I'm making, the Electro Pico, and the extra would be the adapter for microbit. Just one additional requirement would be to get a multimeter, and that would help verify that students have made the right choice with the resistors that they put in their circuit. So this is an extra step which you don't need with Grove. Grove actually saves a lot of time, not only in the wiring, so you just plug in a Grove cable, but it also saves time that you don't have to do this step in checking the interface, particularly where there's a resistor needed to step down the current. The projects, I'll be looking at 6 topics: introducing the CAD program and building the circuit on the Tinkercad. I'll be looking at lights, both simple LEDs and a LED that allows you to generate any RGB combination, and a photosensitive detector. I'll be looking at timing, and the project there would be traffic lights. Then we'd move on to robot circuits, and if we got the Grove kit or the Seeed Studio Kit, we would only build some of the circuits. Whereas if we got the Electro Pico Kit, we would be able to not only build the circuits that I'm talking about here, but we'd be able to complete a robot. And finally, we would look at weather, measuring temperature, humidity, and optionally pressure. And we do a few gardening projects. Then finally, a house alarm, where we build a burglar alarm and be able to detect things like flames. We would have actuators to give us a warning using a buzzer. And in some detail, I based all of these projects on existing material, and I've used the project code number, project KS, means that it comes from Seeed Studio. And these are the projects that I've got in mind. But just about all of these projects also map onto the Electro Raspberry Pi Pico Kit. And these are the other projects and the weeks that they'd be done. And the final schedule and the dates that I'm proposing are here. We'd be able to do the electronics for the rest of this term and for the first 6 weeks of next term. So overall, the Grove Kit, the good points about the Grove Kit: it's tidy, simple wiring, there's less mistakes, and it's a lot quicker. So it'll probably take about half the time to put that together. But it does, it's not really value for money. So when you buy the kit, you have to actually buy extra components to make it useful. And even then, you still need to buy the logo wrappers to make it tidy on the desktop. There's also not much STEM support and not much course material available. There's nothing that integrates it into a complete course. Whereas with the Seeed Studio, it is value for money. You get plenty of course material, a complete course, not only with an outline, but also with the code itself. And all that material is online. But the bad point is that you do need extra time to assemble it. So you probably won't do as many projects. So one project would probably take 2 weeks, whereas with the Grove, you could finish one project in 1 week. And the one that I'm recommending is very similar to the Seeed Studio. Most of the course material from Seeed Studio maps nicely across, and they have additional course material. But the really good point is that the Raspberry Pi Pico supports artificial intelligence projects without any additional cost. And if you buy the Pico with a header, it mounts directly onto the breadboard and saves you from having to purchase a breadboard adapter. Similarly, it does take extra time to assemble the circuits, and you need to purchase that breadboard adapter or microbit. And here are some of the references from Seeed Studio, Seeed Studio, Electro and Tinkercad. So thank you for listening. Bye.